Welcome again. Let's continue our discussion on preparation of amines. Already in the last session we discussed how to prepare amines through the reduction of nitriles, nitro compounds, amides as well as ammonolysis of alkyl halide. Next, the remaining two important neighbor reactions. In this session today we are going to discuss that particular neighbor reactions. One is Gabriel phthalimide synthesis and the one is Hofmann-Bromide degradation reaction. Let's move on to one by one now. That is Gabriel phthalimide synthesis. Gabriel phthalimide synthesis, one of the neighborhood reaction, very important for board as well entrance examination. So keep your concentration. The reaction is too simple. Here Gabriel synthesis is used for the preparation of primary amines. So ಇಲ್ಲಿ ನಾವು prepare ಮಾಡ್ತಾ ಇರೋದು primary amines. That's clear. In order to prepare primary amines, we have to take phthalimide as an initial reactant. So this is what the structure of phthalimide is. Observe carefully. Phthalimide is the initial reactant molecule. So this reaction occurs in three different steps. In all the steps, the remaining structure will retain as such. Only we can see the variation in this particular active site because it contains a lone pair electron. Nitrogen is involved in the reaction. NH, this site is more and more active in the phthalimide. This is an initial reactant when phthalimide is subjected to react with the potassium hydroxide, aqueous solution of potassium hydroxide. Here hydrogen gets replaced by potassium and hydrogen is eliminated in the form of water. Simple. So there is a replacement of this hydrogen atom by a potassium. Here nitrogen carries a negative charge, hydrogen carries a positive charge, so that there is a replacement of potassium by a hydrogen atom. So hydrogen gets replaced here. We are going to get the potassium salt of phthalimide. So instead of hydrogen, we have to write potassium here. Potassium salt of phthalimide. This is potassium phthalimide. Thus obtained potassium phthalimide is now treated with the alkyl halide. Note this point. This is alkyl halide we have to take. So here potassium is now replaced by alkyl group and potassium is eliminated as a potassium halide. KX eliminate after. So instead of alkyl, there is a substitution of instead of potassium, there is a substitution of alkyl group on the nitrogen atom. So that we are going to get alkyl substituted phthalimide. This is nothing but alkyl substituted phthalimide. Remaining all structure in the reaction retain as such. Only we can see the replacement on the nitrogen atom. So this is called alkyl. That too especially N-alkyl substituted phthalimide. So this is phthalimide untreated with the potassium hydroxide. Potassium phthalimide is going to get untreated with alkyl halide. Alkyl halide. So alkyl gets substituted on the nitrogen atom. Thus obtained alkyl substituted phthalimide is subjected to hydrolysis. That too the alkaline hydrolysis. Alkaline hydrolysis means reaction with either NaOH or a KOH. Then we are going to get primary amines with the general formula are NH2. Primary amines for that, and there is an elimination of a byproduct called salt of carboxylic acid, COONA. This is what Gabriel phthalimide synthesis is. So Gabriel phthalimide synthesis is used for the preparation of primary amines, that too aliphatic amines. From Gabriel phthalimide synthesis, we are not able to prepare aromatic amines. Aromatic primary amines cannot able to prepare from this reaction. Why? Because if you want aromatic amines, we have to take aryl halides here. Say for example, if I consider chlorobenzene instead of alkyl chloride, then what happens? Let us consider chlorobenzene instead of alkyl halide. Then what happens? Let's see. See this chlorobenzene, that is nothing but aryl halide. If I consider aryl halide, chloro, halogen atom acts like an electron releasing group. That means it releases the electron towards the benzene ring. And also we know that there is 3 pi bonds already present in the benzene ring. Therefore, benzene is rich in electrons. Are you getting my point? See, already we have 3 pi bonds in the benzene ring, and along with these 3 pi bonds, now halogen is also donating those its lone electron for the resonance. Therefore, benzene becomes still more rich in the electrons. Therefore, since benzene itself is rich in electron, thus the potassium salt of thalamide forms a nucleophile which contains the negative part on the nitrogen atom. This cleavage, the bond cleavage between nitrogen and potassium leaves us a nucleophile. Thalamide nucleophile create ಮಾಡ್ತದೆ. This nucleophile is also carrying a negative charge, and our benzene is also rich in electron. Both negative ಇರೋದ್ರಿಂದ it get repelled each other. So nucleophilic substitution reaction on the benzene ring is quite difficult. It is not at all possible. Quite difficult ಆಗ್ತದೆ nucleophile, because already rich in electrons ಇರೋದ್ರಿಂದ nucleophilic substitution reaction ಆಗುವುದಿಲ್ಲ. What's our idea is, just we have to replace this potassium by this benzene ring. So benzene ಮೇಲೆ ಈ nucleophile ನ add ಮಾಡಬೇಕಿದೆ. It is not possible because the nucleophilic addition reaction, substitution reaction is not at all possible. Why? Because already due to the donation of lone pair electron, halogen and carbon madhike there is a partial double bond is created, and it is quite difficult to break the double bond, and the lone pair electrons is involving in the resonance. Therefore, remember children, benzene easily undergoes electrophilic substitution reaction, but it is quite difficult to do a nucleophilic substitution reaction on the benzene ring. Athwa aryl halides melu kuda same process, same phenomena follow ಆಗ್ತದೆ. ಹಾಗಾಗಿ Gabriel thalamide synthesis ಇಂದ we are not able to prepare aromatic primary amines. This is restricted only for the aliphatic primary amines. Primary amines ಇಲ್ಲಿ ನಾವು ತಗೊಳ್ತಾ ಇರೋದು alkyl halides. Alkyl halides ಆಗಿರೋದ್ರಿಂದ this R group will be alkyl only, so that alkyl amines ಗಳು ಬರ್ತದೆ, not aromatic amines. And once again I would like to repeat the process what is involved in the Gabriel thalamide synthesis. The thalamide is the initial reactant which are treated with the potassium hydroxide. We are going to get potassium salt of thalamide which are substituted by alkyl halide. Alkyl group is substituted with respect to the potassium. We are going to get N-alkyl thalamide which on hydrolysis, alkaline hydrolysis, primary amines are going to obtain by the loss of sodium carbonate as a byproduct. Okay children, so this is a very important reaction for the board examination. And next is the remaining thing, Hoffman bromamide degradation reaction. The last reaction which is there in the NCERT for the preparation of amines, also a named reaction, a very important reaction. So many times in the board as well, in the annual examination, entrance examination, this question is asked. Hoffman bromamide synthesis, Hoffman bromamide synthesis reaction or degradation reaction. Here bromamide is the keyword, you have to focus this. Why? Because Hoffman synthesis this reaction again for the preparation of primary amines again. So here the reactant molecules are bromine as well as amine. Let's consider the general formula of amide. Amide with the general formula RC double bond O NH2, that we know. Yes, when amide on treating with the bromine in the presence of aqueous KOH or NaOH in the presence of base, if we subject amide on treating it with the bromine, then there is a degradation reaction takes place. Degradation means cut out, molecule break agi migration of substituent. Here alkyl group is going to migrate from carbonyl carbon to the nitrogen of the amide which is present in the formula. Andre alkyl group bond anna break ಮಾಡ್ಕೊಂಡು ಸೀದಾ migrate ಆಗಿ nitrogen ಮೇಲೆ ಬಂದು ಕೊಡುತ್ತೆ. So we are going to get RNH2 directly. So after migration primary amines ನಮಗೆ obtain ಆಯಿತು. Then after that means we are removing C double bond O from the amine. C double bond O remove ಮಾಡ್ತಾ ಇದ್ದೀವಿ. How we are removing? we have sodium here, so that sodium on reacts with C double bond, we are going to get sodium carbonate, Na2CO3 agi eliminate ಆಗ್ತದೆ, and remaining things are all byproducts. So we have sodium and bromine andre sodium bromide, NaBr is eliminated, as well water also. These are all the byproducts. So this is how we are going to prepare amines from the, that is primary amines from the Hoffman bromide synthesis. Secondary tertiary amines cannot able to prepare because there is a migration of a alkyl group itself from the carbonyl carbon to the nitrogen. So after getting migration, we are going to get the amines, primary amines. We can prepare both aliphatic amines as well aromatic amines also. Ili R group na alkyl group aru tagobodu, aryl group adru tagobodu. One point you have to focus in this particular reaction is this is the descent series. That means the products always contain one carbon atom less in the number than that of the reactant. That means if we consider ethanamide as a reactant, then we are going to get methanamine as a product. That means ಇಲ್ಲಿ ಒಂದು carbon atom ಅನ್ನು ನಾವು remove ಮಾಡ್ತಾ ಇದೀವಿ in the form of CO3. Carbonate ಆಗಿ remove ಮಾಡ್ತಾ ಇದೀವಿ. ಹಾಗಾಗಿ amide in Hoffman bromide synthesis always the product contain one carbon atom less in the number than that of the reactant. Just balance the equation now. So this is what Hoffman bromide synthesis is. A very important reaction. You have to note this in the entrance examination. We don't know how the question will arise, but focus on the reactants what we are considering. If we have bromine and NaOH, we can also take instead of NaOH KOH also. If you consider here KOH, you have to replace it by K2CO3 as well as a KBr. That's it. So the combination of Br2 and alkali NaOH or KOH, whenever it gets treated with the amide, always we are going to get amine no form because this is one of the entrance examination question. But what happens in the entrance examination, we didn't have a heading at all. If the heading is easy, product, but without heading, the reaction identify here, identify the product. Question mark, you have to think carefully what reactants are going to react in the reaction. So judge so that this combination is very important with the amide. Whenever this reacts with the amide, always there is a migration reaction takes place, so that we are going to get amines, primary amines as a product, and the reaction is known as Hoffman bromide synthesis. And this is about preparation of amines. Amines can be prepared from nitro compounds, nitriles, as well amines through reduction, ammonium sulfur halide, and Gabriel element synthesis, as well Hoffman bromide degradation reaction, or you can also say synthesis. Important reactions ಎರಡರಲ್ಲಿ ಒಂದು examinations ಗೆ board examinations ಗೆ repeated ಆಗಿ ask ಕೇಳ್ತಾನೆ ಇದ್ದಾರೆ ನಮಗೆ. Okay na? So concentrate more on these reactions. After finishing classification, nature, nomenclature, as well preparation, the left portion under amines is only a physical properties as well as a chemical properties. So in the next session, we will directly move towards physical properties of related to amines. Thank you so much.